Hello everyone! In this video we will continue to examine topic 5.3 electric cells, and in particular we will discuss measuring the internal resistance. Firstly, I should mention that right after the previous video on internal resistance, there are a number of really good examples that you should work your way through in the notes before moving on with the video. Alright. To measure the internal resistance experimentally, we're going to use a variable resistor in series with the cell. And what's interesting about this setup is that it blurs the line a little bit between the independent and dependent variables. There are a couple of different ways to analyze this particular experiment. And so I'm going to discuss three different possible linearizations for exactly the same data collected. Fundamentally, what we're going to do is adjust the variable resistor, but by varying the variable resistor directly, and therefore the resistance in the external portion of the circuit directly, we are also varying both the terminal potential difference, delta V, and the current in the circuit. As a result, you can do the straightforward analysis and linearization that we had discussed from the previous video with delta V on the vertical axis and the current on the horizontal. It gives you a slope of negative R and a y-intercept of the EMF itself. But there are two other possible linearizations you could undertake in order to analyze this same data. The first acknowledges that more often than not, we are directly modifying the terminal potential difference, or potential difference in general, and then the current is viewed as the outcome. So what we're going to do is just going to rearrange this relationship here. So our EMF is equal to the terminal potential difference plus I times R, so we solve for I. That gives us a y-intercept of the EMF divided by the internal resistance, and a slope of negative 1 over the internal resistance. But the same information that is here in this graph can also be found in this graph. It's just that the values are adjusted. All right. Given that, there is actually one more way to analyze this. This is a little less common, but if it strikes you that we are in fact directly adjusting the resistance of the variable resistor, this method of linearization will probably be to your taste. So we directly adjust the resistance of the variable resistor, which means we want a linearization that will give us a function of one of the other variables versus R. And to do this, we're going to use 1 over I on our vertical axis. We're going to start again with our foundational equation relating the various variables, and we'll solve for 1 over I. So if you solve for 1 over I here, you get 1 over I divided by R plus little r divided by the EMF, and this can be interpreted as the slope of our graph. So 1 over the EMF is now the slope of this particular graph, and the y-intercept is the internal resistance divided by that same EMF. Okay, these are three different linearizations for this experiment. All of them are good. Some of them are easier to work with or sort of convey sort of different sorts of information. You should be prepared to handle any of these three.